Section 9.3. Resistors in series and parallel connection. Resistors are said to be connected in series, when they directly connected end-to-end with no branching point in between them. Since all the current flowing through the first resistor has no other way to go, it must also pass through the second resistor and the third, and so on. The resistors in series have a common current flowing through them, as the current that flows through one resistor must also flow through the others, as it can only take one path. The amount of current that flows through a set of resistors in series will be the same at all points in a series resistor network. This total resistance is generally known as the equivalent resistance. For calculating total resistance of the circuit when connecting together resistors in series is given as: resistors are said to be connected together in parallel when both of their terminals are respectively connected to each terminal of the other resistor or resistors. In a parallel resistor network, the circuit current can take more than one path, as there are multiple paths for the current. Since there are multiple paths for the supply current to flow through, the current may not be the same through all the branches in the parallel network. However, the voltage drop across all of the resistors in a parallel resistive network is the same. Then, resistors in parallel have a common voltage across them. For resistors in parallel, the equivalent circuit resistance is calculated differently. The reciprocal 1/R value of the individual resistances are all added together instead of the resistances themselves, with the inverse of the algebraic sum giving the equivalent resistance as shown.